stand up and welcome to the new episode of Acids, Bases and Salts. In the last class, we have learned about what are acids and bases and what are the chemical indicators, natural indicators, and we learned some reactions of acids and bases. Right? Now we are going to learn what are the things that are common between acids and bases. Okay, so let's get started. Commonalities between all acids and all bases. Acids contain H plus ions as cation and anions such as Cl minus in HCl, SO4 2 minus in H2SO4, NO3 minus in HNO3, and so on. So what is this statement saying is that every acid contains a H plus cation. Cation means a positively charged species. So a positively charged species is present by default in all the acids, which is H plus, and it reacts with other negatively charged species which are called anions, like Cl minus, which is chlorine anion, chloride ion, and SO4 2 minus sulfate ion. Okay, and NO3 minus nitrate ion in HNO3, nitric acid. Similarly, in bases, there is an anion. In acids we have cation by default, and in bases we have anions as default, which is OH minus, one oxygen and one hydrogen. So this is the anion that is present in all the bases by default, and cations like sodium, magnesium, etc. react with OH and form bases like NaOH and magnesium oxide. Now let us learn the effect of adding acids and bases to water, which is also known as hydrolysis. Suppose we are taking sulfuric acid, okay? We can take any acid, doesn't matter, it should be concentrated, okay? And you have to do this in laboratory, don't do at home. Okay, if you add any concentrated acid like sulfuric acid to water, the acid dissociates and H plus ions are released into the water. The separation of H plus from H2SO4 is only possible in the presence of water. If you take any other aqueous solution, any other liquid other than water, it will not dissociate. Okay, H plus ions are not formed in the water. So this is the reaction. H2SO4 plus 2H2O gives rise to 2H3O plus SO4 2 minus. This H3O plus is nothing but H plus, your hydrogen ion. H3O plus, why have we written H3O plus, is because hydrogen ions do not exist alone. They are not just alone. They are not like H plus, okay, in nature. They exist as H3O plus in the nature. Further, moving on the other hand, if you bases, when we add bases to any aqueous solution, we get OH minus ions, which are anions. We just now learned that by default all the acids contain H plus cations and bases contain OH minus anions. So these are what are being released when these acids or bases are added to water. For example, these three are the examples. Here we are seeing that NaOH is being reacted to water to form Na plus sodium cation and OH minus anion. Similar is the case with KOH and MgOH taken twice. All bases don't dissolve in water, which means that there are only some bases which, when added to water, dissolve completely. There are some other bases also which don't dissolve in water. They form a layer like oil over water. So the bases which dissolve in water are called as alkalis. This is an important note to be remembered. These can be asked in 1 markers. Now we know that acids generate H plus ions and bases generate OH minus ion. Now it is easier to visualize the neutralization reaction, which is the reaction between acids and bases. So we can summarize the neutralization reaction like this: acid plus base gives rise to salt and water. We already have learned this. HX plus MOH gives rise to MX plus HOH, which is H2O. Here in HX, X is a halide, which means they are the elements from the 7th group, halogens: chlorine, chlorine, bromine, and iodine. And M is nothing but your metal, any metal, and sodium, magnesium, aluminum, anything. So the halide from HX and metal from MOH, halide from acid and metal from base form a compound after reaction, and water is formed. This is a salt that we get, and this is water. So this can be also written as H plus. If we remove this chlorine or bromine or fluorine, anything, we get positive ion, which is H plus. And similarly, when we remove metal from MOH, we get OH minus. H plus plus OH minus gives us H2O. As simple as butter, right? Now let us see what this process is called. When we are adding any acid or base to the water, what is this process really called? What is happening here? The addition of acids or bases decreases the concentration of ions. When we add an acid or a base to water, the concentration of ions H plus or OH minus decreases in the base or in the acid. So this process is called as dilution, and the respected acid or base is said to be dilute. Okay, it is less concentrated than before. Caution: very important thing to be remembered, that when we add acid or base to the water, it forms a dilute solution of acid or base. If you do the vice versa, which means if we add water to concentrated acid or base, it is a highly exothermic reaction. A lot of heat is released, and there may be a chance that the container in which your acid or base is, it can shatter completely, and the contents of that beaker can splash off onto your skin and cause severe burns. So this is a very important point that is to be remembered, especially when you are doing reaction in the laboratory. Okay, so look out for this warning sign on the containers of the concentrated acids or bases. So that's all for this episode. Thank you guys. See you in the next part of this chapter. Please like, share, and subscribe the videos if you like. And if you have any queries, doubts, drop down in the comment box below.